Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am Mr. Kadim Khan and I am a lecturer in the Institute of Computing, Kuwait University of Science and Technology. Today we will take lecture number 17 of the subject of software quality engineering, in which we are going to discuss software testing for software quality engineering, and the subtopic is the unit testing methodologies. Dear students, unit testing is very much important in the software testing, in which we test the individual unit or a module of the program. So here in this lecture, we are going to discuss unit testing methodologies in detail. This is the discussion agenda. It contains the topics of laws of testing. Then we have the testing stages, unit testing, white box testing fundamentals, types of code coverage. Then we have the basics part testings. Here we will discuss CFG, that is control flow graph, and then we will discuss different examples of the CFG. And then we have the loop testing, and in the loop testing we have two different examples of the loop testings. Then we have simple black box testing, boundary value analysis, and then we have boundary value analysis test case preparation. That is very much important, that how we create the test cases using boundary value analysis. Then we have the examples of the boundary value analysis, and at the end we have the random testing. Now first we need to understand the laws of testing, because the laws of testing help us about the guidelines of the software testing. Now the best persons to test your code is someone else. So mostly we do not test our own code. So another person will test our code. So the best testing is performed by the other persons for our activities rather than testing ourselves. Next one is that a good test is one that finds an error. So a successful test is that one test which finds an error. Testing cannot prove the absence of errors. So the testing should prove the presence of errors instead of the absence of the errors. Complete test coverage is impossible. So concentrates on the problem areas only. So 100% complete coverage testing is not possible. So we have to concentrate only on that particular modules or areas where that problem arises. It costs a lot less to remove bugs early. So when we want to remove the bugs in early phases of the software development, then it is in fact less costly than removing the bugs in the later phases. So in the early bugs will be removed with a less amount of cost. Now testing strategies. We have multiple testing strategies here. First one is called unit test, in which the modules of softwares is tested isolatedly. That means that module by module testing is called unit testing. In the integration testing, we test the designs of the software. By design of the software, it means that when different components are designed with each other and then they integrated, and then they pass data from one component to another component, then that is called integration testing. For example, when we want to integrate the database systems with our front end, with our graphical user interface, then that is called integration testing. Validation test is performed based on the user requirements. When the user requirements is validated with our systems, then that is called the validation test. System testing. In the system testing, system engineer perform the system testing, in which all the software and hardwares are tested in one project. So system testing is the last testing in which all the software and hardware is tested with each other. Now unit testing. In the unit testing, we perform either white box test or the black box test. We perform both white box and black box testing. In the white box testing, we perform that the modules are tested based on some input, output are based on some sort of the source code. In the white box testing, we test the program statements of the modules, that all the program statements are executed thoroughly. While in the black box test, we test the system based on their functions. There is based on their input output, and then we test the system. In the black box testing, we test the software based on the requirement specification documents, and all the functionalities is tested based on that documents. It is also called functional or behavioral testing. Now, what is the proof of correctness? The proof of correctness is the mathematical based analysis testing. So here we will perform certain formulas, or we will perform testing based on certain equations or formulas. These are called the matrices of the software testing. And it is similar to the problem theorem, that when we prove that this theorem works correctly for the particular problems. So here we will test the software based on certain mathematical equations. White box testing fundamental. White box testing is very much expensive than the black box testing, because in white box testing we have to monitor and we have to test each and individual statements of the program. While the white box testing is appropriate when we must ensure that the calculations are correct. So means that all the calculation performed by the testing is quite correct, analysis are quite correct, then we says that white box testing is also correct. So covering each and individual path through the module is usually not practical. The white box testing is very much difficult activity, and covering of each and individual module is quite difficult, because there are thousands and million lines of codes in one program. So that's why testing individual program is quite difficult. So for example, if we have 10 different statements, if then statement in the program, then there requires 2 raised to power 10, which is 1024 test cases. So all these 1024 test cases cannot be performed. So that's why we have to test the system based on some particular statements. So instead of the base number of tests on the complexity of the modules, we cannot perform large number of tests here, because that requires a lot of resources and time as well. Now, types of code coverage. Types of code coverage means that our program should have completely, our testing should have completely performed the testing for each and every statement of the programs. So when we perform all these 5 tests, then we says that the system has been tested completely by the white box testing. First one is the function coverage. Function coverage means that all the functions in the programs are executed properly. So has each every function in the program has been executed or not. Next one is called the statement coverage. In the statement coverage, each statement, that is each lines of the source code, has been executed. So we have to make sure that each and every line of the source code has been executed. Next one is the conditional coverage. In the conditional coverage, we have to make sure that every condition which has the true false decision statements has been executed. While in the path coverage, we have to make sure that each path in the program has been covered or they are being followed. So here every possible route through a given part of the code has been executed. While in the entry exit coverage, we have to make sure that all the entry and exits criteria are the coverage of the function has been executed. Here the entry means that the possible parameter list, and exit means that the possible return of the function has been executed. Now this is the examples. Here as you can see, this is the example of the white box testing. For example, we have a code which is a function here of the return type integer, and the function name is example1. Int value is boolean condition 2. These are 3 different parameters of the functions. Here there are two conditional statements. If condition 1 values plus plus, if condition 2 values minus minus, and return the values at the end. So there are two different conditional statement, and the conditional statements increment the values, and the second conditional statement decrement the values. So total statement coverage with one case true true. So if you want to cover the statement coverage here, that means that all statement must be executed. So we have to pass both true values to these conditions. And total path coverage is for true true, true false, false true, and false false. So the exhaustive coverage is that one, that which is the path coverage, that we have to test the system based on true true, true false, and false true, and false false. So we have to provide certain values which well covers all these tests. So this is called path coverage. You can see that the path coverage is much exhaustive than the statement coverage. So but total path coverage is usually impractical. So for the large program, total path coverage is impractical, and because it requires a lot of time and resources, so basis path testing is conducted here. So the path test is conducted here. The path test is conducted based on the matrix, which is in fact invented by the McCabe matrix, and this is performed by using the CFG. So here we will draw the control flow graph, that is the CFG, that which determines the cyclomatic complexity. The cyclomatic complexity is based on three different matrices. First one is called cyclomatic complexity is equal to number of bounded areas plus 1, and second one is cyclomatic complexity is equal to number of conditional statement plus 1. Number of bounded areas are those areas which are closed areas in our CFG, and one is the constant values. Second one is number of conditional statement plus 1. Number of conditional statement is all the conditional statements in our program. It can be computed from our program only. And the third one is also computed from the control flow graph, that is equal to cyclomatic complexity is equal to number of edges minus number of node plus 2. So maximum number of tests can be in fact the values of the CC, which is the cyclomatic complexity. Derive a basis of independent paths. It also derived the independent paths. The paths are the paths from which the program execution will be traced, and generates the test data drive for the each path as well. So the CFG also drive the data for each path, that this data is required to be performed by that testing. Now, how we can draw the CFG at the control flow graph of the programs? If the program is based on simple sequence statements, then we can draw the CFG like this one. And if the program is based on the if else statement, we can draw the CFG like this one, that if the condition is true, then this statement will be executed. If false, then this statement will be executed. And all these two statements, either failed, pass or failed, that is true or false, will be combined with each other on this connector. And this is the while loop. If conditions, then the body of the while loop will be executed, and this will be executed number of times. If the conditions remains false, then the another statement after the while loop will be executed. And next one is do until loop, that is also called do while loop, in which first the body of the loop is executed, then the condition is tested, and when the condition become true, then again the body of the loop will be executed, and so many times this will be executed. If the condition becomes false, then the next statement after the do until loop will be executed. This is the case statements. Here will be the case values, and here will be the switch statements, and there will be multiple case values. So if this is the switch statement, there are four possible, for example, case values, and any one among them will be executed based on the certain values. And at the end, all these values will be combined with each other, and the connector will be executed. Now, dear students, here we will perform an example. Here, The example is the example of a functions which will increment or decrement to one different values, that is values, and the values will be incremented based on certain conditions. If the condition is true, then the values will be incremented, and if another condition is true, then the value will be decremented and return statement will be executed at the end. So int example 1, int value, int boolean condition 1, boolean condition 2, there are three different parameters here. One is the integer and two are the booleans. Now, if condition then value 1, first of all, we need to number or list down these statements, which is the part of the body of the function. 1, 2, 3, 4, 5. So, for 1, if this 1 is true, then 2 will be executed, otherwise 3 will be executed. If 3 is true, then 4 will be executed, otherwise 5 will be executed. So, you can see that there now becomes two bounded areas. So number of cyclomatic complexity is equal to number of bounded areas plus 1. So 1 plus 1, 2 bounded areas, so 2 plus 1 is equal to 3. Second method is number of conditional statement plus 1. There are two conditional statement plus 1. One this one and second one is this one. So 2 plus 1 is equal to 3. And third one is number of edges minus number of node plus 2. Number of edges, you can see that there are 6 number of edges. 1, 2, 3, 4, 5, 6. So, and number of 5 is are the nodes here. So, number of edges minus number of node plus 2. So, 6 minus 5 plus 2, which is equal to 3. So, there are three possible paths here. So, first path is 135. 135. So, when we provide the false values to these if statements, then this will be checked, then third will be checked, then fifth will be executed. So 135 is the possible path here. Second one is that if first condition is true, then 1, 2, 3, 5. So, and second condition is false, then 1, 2, 3, 5 will be executed. And the third possible test will be that if this condition is true, 1, 2, and this condition also true, then 4, 5. So 1, 2, 3, 4, 5 will be executed. This is the another examples. First, we have to list down the values of the statement in the function. So we have list down here, and so float values, which is the variable values, it is initiated with 0.0, and it is the integer which is initiated with 0. Then we have the for loop from 1 to size of the arrays. If balance is less than 0, that means if the values is negative, then total plus is equal to balance is I. Then the values will be in fact added with the total values, which is the 0, and then the count plus this statement will be executed, which means that it will count the negative values end of if in the for loop, and at the end return statement will be executed, and return statement is the total divided by count. Now, what will be the correspondence CFG for this program? Here you can see that first 1 will be executed, then 2. 1 and 2 are the sequential statements, and then 2 is the loop statement. So on the 2 statement, the first of all body of the loop will be executed, which is the if statement, and if the true it is true, then the loop will go up, and if the 3 is false, that is if 3 is true, then 4 will be executed, and then the body of the loop will be executed and condition will be tested here again, and then in the body of the loop there is 3 and 4, these two will be executed. If 3 becomes false, then again condition will be tested here, and if this loop is terminated, then fifth will be executed, which is the return statements here. So now you can see that we in fact draw the compute the cyclomatic complexity of this program and this CFG. So first one is the number of bounded areas plus 1. There are two bounded areas, this one and this one. So 2 plus 1 is 3. Second one can be computed from this program, which is the number of conditional statement plus 1. There are two condition statement. One is here in the loop, and second one is in the if statement. So 1 plus 1, 2, 2 plus 1, 3. So number of conditional statement plus 1, that is 2 plus 1, which is also 3. And third one can be calculated from the CFG. Number of edges minus number of node plus 2. So here is the 1 edge, 2 edge, 3, 4, 5, 6. You can see that there are 6 edges here and 5 nodes. So 6 minus 5 plus 2 is also equal to 3. So by all means we get the 3 values. So that means that there will be 3 different possible paths. First one is 1 to 5. 1 to 5 means that when the array size is 0, that means that there is no element in the arrays. Then the loop will be exits and automatically the return statement will be executed. So 1, 2 and 5 will be executed. Second one is 1, 2, 3, 1, 2, 3, 2, 5. So 1, 2, 3, 1, 2, 3, then again if that statement becomes false, then 5 will be executed. So 4 will not be executed. 1, 2, 3, then 2, and then 5. This is the another statement. This will be executed when the array size is from 1 to 25. Means that if there is single elements in the arrays are the all 25 elements in the arrays, then this statement will be executed. And the last statement will be executed when there is the array size of 1 to minus 25. That means that there is some negative values in the arrays as well. So the statement will be executed like this one, that 1, 2, 3, 4, then 5, then 2 and then 5. 1, 2, 3, 4, 2, then 5. Because this statement is executed for the negative values, which is the if statements here. So if this becomes true, then 4 will be executed and 2 and then 5 will be executed. Now here is the loop testing. Loop testing will be executed when the array size is greater than our maximum. So for example, if the number of test cases is required when the size is 0, so no test case is required when the size is 0. N is equal to 1 if there is one element in the array in our test, then the size will be 1. Size value 1 means that array size will be 1. If maximum minus 1, if the size is 999, that means that if the maximum values in the arrays is the 1000, then number of element to be executed is maximum minus 1, which is 999. And if there is a maximums size of the arrays, that means that 1000, then maximum will be executed. That means that 1000 will be executed. And when we have 1001, means that when we want to test this loop for the greater values, that means when the loops will be terminated for 1001, then maximum plus 1's elements will be required for the testing. So but already the array has only 1000 elements, that's why 1001 will be the test cases, because for the maximums, for example 1000, then 1001 will be incremented here, and then it will also be tested for 1000 where the loop will become false and return statement will be executed. So that's why maximum plus 1 is the required number of test cases. Next one test is called black box testing. In the black box test, we test the functionalities of the system. The black box testing is quite easy to be computed because we just test the system based on the input and output. And we can use the typical data. That means that we can use any types of data here. Boundary value analysis are the extreme data is also required here. Boundary values are those values which lies on the extremes or on the boundaries. For example, minus values, that is the least values, and the greater values, which is the largest values. These are also called the extreme data. Also, we can perform based on some bogus data. Bogus data means that here we will take some random values, then based on that bogus data we can perform the testing here. Boundary values analysis. What is the boundary value analysis? Basically, it is the form of the black box testing in which we test the softwares based on some equivalence partitioning. It is the similar based on equivalence partitioning. For example, medium values and the values less than medium value and the values greater than medium values, and Also the extreme values here, that is the negative value and the most positive values here. Now it is the one of off by one is the most common coding errors. Off by one means that when we have to test the system based on the smallest or the based on the largest values, then the system will in fact throw the certain errors here. For example, the factorial of minus values is not possible. So then the system, if the system computes the factorial of negative values, then means that it has certain problems. Errors usually occurs near the end. So mostly when we identify the errors are usually identified in the end of this of the statements. Now, how we can perform the boundary value analysis? We can perform boundary value analysis based on the, for example, in the range. So the range will be from the A to B. A will be the smallest values, while B will be the largest values. For example, 0 to 100. So 0 will be the smallest values and 100 will be the largest values. So we can test, for example, first based on 0, then based on 100, then based on negative values, then the 0. That means that negative value -1 or -2 or -3. And also we will test the system based on the positive values, that is the larger values, which is the greater than 100, which is for example 101. So we will do the same for the output as well. We will also examine the output based on 4 different values. Now, for example, if we want to test the system based on the range of the 0 to thousands, so the size of our input should be from the 0 to 1000. So arrays of the balance elements are positive or negative floats. That will be either positive or negative. Positive means that all values including from 0 to thousands and in also 0 inclusively 0 and 1000. And negative means that the values which is less than 0, that is -1, -2, etc. Output is average of negative balance. So here, better is to test based on the average of 0 to 1000, which is 500. So this will be the exhaustive testing and it will represent the whole testing, because 100% coverage is not possible, and this that's why we can test the system based on some negative average negative values or average positive values. So next one is the second examples. The second example was the counting the negative values in the function. So if the size is zeros, then that means that there will be no negative values. If the size is ones, balance is first negative values. If the size is 1, the balance is either first negative value or the first positive values. If the size is 1000, then all the negative values will be there or all positive values will be there. If the size is 1001, we cannot identify the negative or the positive values here. So based on the output boundaries, we will test the system, a test where the average negative is huge. So when the average negative is the huge number, then we can say that it gives us 100% testing coverage. And if the average negative number is smaller here, we can also say that it gives us 100% average negative test here. Next one is the random testing. Random testing is performed based on some random input output. So it is a method where just randomly generated test data is performed, and then based on that random test data we test the system. It has the advantage that it is quite easy to generate the lot of test cases as compared to lot of test cases. We just test the system based on some smaller random values. While it also has the disadvantages that you are very lucky that that particular random test will find the errors, because mostly the random values do not identify the errors here. So that's why for the random values we cannot make sure that we are not 100% sure that it will catch the error. Dear student, this is the end of the lecture. If you have any question, you can ask the question through the email. Also, these are certain books you can study more for these topics. Thank you very much.